Hello everyone. Today we will talk about motion. Motion is physical phenomena that we see, we face every day. At the moment you are listening and your hands, your head is moving. Yes. When you walk, when you run, when you drive a car, everything around us in motion. There's so many examples and we see it every day. Our aim here in this video to understand the foundations, the main ideas, to understand the main ideas about motion. There are four basic types of motions. Basic types, main kinds of motions. First one, as you see in this picture, linear motion. Linear motion, it means this is a motion only in one direction. You don't change your direction. If you move straight in one direction, we call this kind of motion linear motion. Linear means straight. Second type is circular motion. As you see here, this is a circular motion. When object comes to one point during the certain time. Yes. What is the difference between linear motion and circular motion? In linear motion you just move straight and forward. You don't come back. Yes. In general, in circular motion, time by time you will be coming to the same point. For example, when you start your motion for, let's say, from here, then after 5 minutes you will be again at this point. Again, after one more 5 minutes, again you will be here. So from here you can understand that this is a circular motion. Projectile motion. Third type of motion is projectile motion. What is a projectile motion? When height and range changes same time. Yes. When you throw, for example, something, object, in this direction, let's say this is the angle, initial angle with horizontal surface alpha, we know that this object will come back to the earth, to the ground, to the surface due to the gravity, because gravity will not allow to go away, far away from the ground. Yes. Here the range means horizontal displacement, horizontal motion, and the height, vertical motion, vertical displacement, they both change. So that's why we call it projectile motion, or we say motion in two dimensions. In linear motion, only range changes. Yes. Or if you throw it upward, for example, only height changes, only, just in one dimension motion. But in projectile, both height and also range, horizontal range changes. Rotational, last one, rotational motion. This is a kind of motion which you can see in this book. Yes, in this picture, in this figure. So we have a toy, the famous toy, and it is rotating. So it is rotating around its own center, so we call it rotational motion. These are the main four types of motions. We will not explain details. Details will come later in next courses, in next lessons. Here we are just trying to understand the main ideas about motion. Let's continue. In order to understand the motion, one of the ways is to draw a diagram. And you should be able to study the diagrams. Diagram means picture, figure, yes? So for example, let's study this diagram. What we can see, there is a boy and he is moving with the help of skateboard. So we have 4 positions, which means this picture was taken with same interval. So let's say 1 second. This is a 0 second, after 1 second, after one more 1 second, after one more 1 second. So basically interval taking picture is same. Now we need to study, you should be able to study this diagram. What we can say? Visually, you don't need to take ruler and measure it. It's a simple, visually we can see that distance between 2 pictures, this distance, roughly approximately same. Yes, all this distance, visually of course. So what we can say? According to this information, we can say that this is a motion with constant velocity, constant speed, because during each 1 second, this boy travels for the same distance. It means this boy has a constant speed and moving to the right. Yes, for example, equal speed, constant velocity, or sometimes we call it uniform motion. Now let's come to the second diagram. Same picture was taken with the same interval after 1 second. And what we can see that the distance between 2 pictures, initial first pictures, is smaller than next distances, and that one is smaller than the next one. So what we can say about this motion? This girl is running. Logically we can say that this girl speeding up, or speed or velocity of this girl is increasing. It's simplest because distance is increasing, constantly increasing. It means velocity or speed of this girl is increasing. Sometimes we say acceleration. Yes, she is accelerating. Let me write it here. Acceleration. So she's accelerating, speeding up. Last picture, last diagram. Again, it was taken with same interval, with the same interval time, and this initial distance is bigger than next distance, and that one is bigger than next one. So what we can conclude? We can say this car is slowing down. Velocity decreasing. Velocity is decreasing. It means after some time it will stop. Velocity will become 0. Or we say deceleration. When speed or velocity decreases, we call it in English deceleration. Now there is a simple one question to think. Stop to think. We will stop here and we'll try to think. Question: which car is going faster, A or B? Assume there are equal intervals of time between the frames of both videos. So as you see, we have 2 diagrams, yes, A and B. In A, red car is moving to the right. This is the direction of the car, yes, moving to the right. In second diagram, in second figure, in second picture, yellow car is moving to the left. So their directions are different, opposite directions. And we know that these pictures was taken with equal interval of time. So now we need to compare the distance between 2 picture says 2 frames. So what is the distance between these two cars? Maybe 2 centimeters approximately, roughly. Between these two pictures, 2 frames, it's more than 2 centimeters. It's obvious, it's visually. And what we can say, yellow car is moving faster or with bigger, greater velocities than red car, but to the left. Red car is moving to the right. So this is the difference. Now let's answer to the question, which car is going faster? So it's obvious that yellow car is moving faster. But direction is wrong direction, is left direction. Now, small hint, small method, how to solve this kind of problems. Of course, when you solve problems, we cannot draw in real life each time this kind of cars. Yes, it's impossible, and we cannot waste our time by drawing this kind of figures as figure of the car, because our aim is to solve the problem. Our aim is not to paint difficult, complex figures. So just for us, we can take car as a point, just small point. This point is for us will be car. So don't try to draw the figure of car or house, I don't know, building, plane, trains. To make it simple, our aim is to solve the problem. Our aim is not plane. Our aim is not to draw the train. We focus on physics, so for us, car, train, size is not important. We consider it as a point, small point. We assume that all mass of the train, object, plane is concentrated at this point, and we call it simply particle. Particle or point. Why we use point or particle? Because it's simple and it's easy for us to number. For example, instead of drawing these 4 different red cars, it's simple for us to show it as a point. Yes? This point is car for us, and it's simple for us to describe it. We can just call it initial point 1, second point, third point, point number 4. As you see, it becomes very simple question, and we can number all points, and it will be simple, useful, convenient to solve further this kind of problems. Now let's stop to think again. We have 3 figures, A, B, C. Now we need to describe these 3 motions. So let's start from diagram A, figure A. We have a numbers 0, 0.1, 0.2, 3, 4, 5. Again, these frames was taken at equal interval time. So what we can see in figure in diagram A, the distance between adjacent numbers increasing, yes, increasing, and so on. Distance between 0.2, 3 is smaller than distance between 3 and 4, and the distance between 3 and 4 is smaller than next distance, which is between 0.4 and 0.5. So what we can say, this is a motion with acceleration, basically speeding up. Velocity is increasing. In figure 2b, in figure B, visually we can see that distance between adjacent points are same. Yes, this distance equal to this one, this one, this one. So what we can say about this type of motion, this is a motion with constant speed, or we can say uniform motion. Next one, it's vice versa. opposite to the diagram 1. The initial distance between 0 and 1 is bigger than distance between 1 and 2, and it's bigger than distance between 2 and 3. So this is a motion, decelerating motion. Speed is decreasing. Velocity is decreasing. It will stop after some time. Now, position, time, displacement. Why we need these physical quantities? To use motion diagram, the diagrams that we just explained, you would like to know where the object, basically its position. Yes? To solve problems, you should know where object is located at certain time. So this is one of the questions. So position is important, and also time is important. We need to know the position, the place, location, and the time when this object was at that certain position. Time is also important. Position measurements can be made by laying a coordinate system grid over motion diagram. So in order to find position, or in order to explain position, it's better to use coordinate system grid. You know what is a coordinate system? Yes, x, y, etc. Simple. You can then measure x, y coordinates. X is a horizontal coordinate, y is a vertical coordinate, as you know. You can then measure x and y coordinates of each point. Point means, for example, initial point, final point, or point during certain time, yes, at certain time. Of course, the world does not come with coordinate system attached. This part is very important. Of course, the world, in our real life, there is no coordinate system attached. We don't see it in real life, yes? What does it mean? A coordinate system is an artificial grid. Artificial. It's artificial. It doesn't exist in real life. I mean, it's not matter. It's not something that you can touch. That you place over problem in order to analyze the motion. Just this is one of the methods to solve the problem or to analyze the motion. Just we draw artificial grid, coordinate, and because it makes our life or our solution of the problem simple. You place the origin of your coordinate. Origin is beginning. You place the origin of your coordinate system wherever you wish. This part is also important. You can locate it wherever you want. And the different observers of moving object might all choose to use different origins. This part is not important for now. Important thing, in order to describe position means location. It's better to use coordinate system, XY coordinate system, and it's totally up to you where to start this coordinate system. Starting point, we call it origin. Yes, x0, y equal to 0. We call it origin. Time, second important physical quantity is time. So it's important. We should know the time. At what time it was at certain location, at certain position. So time is important. Basically, time is, in a sense, is also coordinate system. You see, interesting. Time is also coordinate system. You may never have thought of this way. Really, people don't think that time is coordinated. Time is simple for us. Beginning time, end time, middle time, that's all. Actually, we can consider it also as a time, because time is going forward. It's always going forward. You can pick up an arbitrary point in the motion and label t equal to 0 seconds. T equal to 0 seconds means basically beginning of something, beginning of the motion, start of the motion. This point, we just call it time 0. Yes, time equal to 0. It means beginning. Now let's come to the coordinate system. So in diagram A, we have a object, let's keep it simple, which is sliding downward, yes? So x coordinate is changing, y coordinate is changing. Now we know that we can choose as the origin of the coordinate any point, but of course we need to choose the way which will be simple for us, yes? Usually what we do, we choose like this usually. This is x coordinate, this is a y coordinate, this is origin. This is origin, where x equal to 0, y equal to 0. And you can see it in next diagram. Let's continue with the second diagram. X and y coordinate is given. So let's number it. This one is a 0, 1, second point, 0.3. So times 3 means this is the time at this point. So after 3 seconds, after starting the motion, after 3 seconds, it will be at this point. x3, y3, these are the coordinates after 3 seconds. That's why we call it x3 and y3, which is equal to, for example, 15 meter and 15 meter. So position is an arrow which is connecting origin of the coordinate and the point that we are considering. For example, this one. And you should remember that position is a vector quantity. In previous lesson we explained the difference between scalar and the vector. So this is a vector, position is a vector, as you see, direction is given with arrow. This is a vector, and let's call it R3. R3 equal to 21 and 45 degree. 21 means this is the length of this arrow, the length of the position or distance between this point and this point. 45 basically shows its direction. This angle with horizontal coordinate, with horizontal surface, 45 degrees. This is information about position. Let's call it R3. So R3 is a position at T3 time, this one. Let's call it R3. And we have a position, we call it R4. This is a position at time T4. We call it R4. Basically, point 3 is a starting point, yes, beginning point. Point 4 is a final point for us. So the difference or vector that is connecting points 3 and 4, we call it displacement. So this delta R means change. Let's change R4 minus R3, and we shortly call it displacement. So as you see from this figure, displacement is a change in position. Change means R4 minus R3. Final position minus initial position will give you displacement. This is the addition of two vectors, because position R3 is a vector, R4 is a vector, so you need to add, you need to subtract. So this is about adding, subtracting vectors, and we will explain it later with details. For now, it's enough to know that displacement is a change in position. Final position minus initial position will give you displacement. What is a displacement? Displacement is basically the shortest distance, let's say, between final and initial point, and the direction is towards the final point. This is a definition of displacement. I will not talk about time. Time is simple, and you should remember that it's also kind of coordinate and it always moves forward. Now let's come to velocity. Velocity, this is also vector quantity. When you talk about velocity, when you describe some motions in terms of velocity, it means you are giving information about its direction. So what is a velocity? Let's say 10 meters per second. This is not velocity because there is no information about direction. You need to draw it, for example, 10 meters per second. So this will be velocity because there is information about its direction. It's moving to the rightward, for example, yes, or it's moving upward. Then this will be velocity. When you talk about just numerical value, just magnitude, let's say car is moving with velocity 10 meters per second. No information about its direction. Then this will be speed. We call it speed. It has a special name. And this is a scalar quantity. Speed is a scalar quantity. Velocity is a vector quantity because it comes with direction. Average speed. Average speed can be calculated with this equation. Distance traveled, you need to divide by time. Time interval spent traveling. Basically, this is the time that you spend, that object or car spends between initial and the final point. Total distance traveled, you need to divide by time interval. So it will give you average speed, which is very simple. Let's shortly, in terms of symbol, you can say d over delta t, or x over time, or s over t. It's totally up to you. Symbols are not too important, but you should know that x is distance, s is distance. It was speed. What about velocity? Since velocity is a vector quantity, direction is important. Then you need to use displacement because displacement is coming with direction. Displacement is a vector. Distance is scalar. Distance is scalar quantity. Let me write shortly like this. Displacement is vector quantity. It has direction. You should show it. So this is the distance, for example, 10 meters. Displacement is this one. It has only one direction. This is a displacement. In order to calculate velocity, you should use displacement because velocity is a vector, displacement is also a vector. So very similar equation. Displacement you should divide by time in order to get velocity. For speed, you need to use scalar because speed is scalar. So distance you need to divide by time. Motion diagrams with velocity vectors. So we know what is a diagram. Basically, this is a figure of the motion, yes, and usually we use particle method, point method to describe objects, to describe vehicle, for example. Now let's add to this diagram velocity vector. It's a vector. So now let's study this diagram. What we can see points, initial point, 0 point, first point, second point, third point, for example. And we can see green arrows. These green arrows, in this case, for this problem, for example, explains velocity. You see, this is a velocity. Yes, V0, V1, V2. And we have a second diagram and also describe it, and it also shows velocity in terms of arrows, green arrows. The size of these green arrows corresponds to its magnitude. So all these green arrows directed to the right. It means in first diagram and in second diagram, both objects, let's say, moving to the right. This is information about direction. The size of the arrow, size, this is a size, yes? You can use ruler, for example, to measure the size, but visually it's obvious that the size in the first diagram is bigger, larger than the size of the arrow in second diagram. What does it mean? It means the object in the first diagram, in this diagram, let me call it 1, yes? This is first diagram, second diagram, moving faster than the object in second diagram. So the size of the arrow is also important. Direction is also important. Let's solve example 5. You drop a soccer ball from your third-story balcony. Use the particle model to draw a motion diagram showing the ball's position and the average velocity vectors from the time you release the ball until the instant it touches the ground. So we have a balcony. Balcony is not important. Its important point is it's falling. The ball is falling from the certain height. So initial point, let's call it 0. After 1 second, it will be here, for example. After 1 more second, it will be here. Why? Because it will accelerate downward because due to the gravity, yes, you know. So the distance will increase or displacement will increase. So this is a point 3. This is how it will look like in real life. Use a particle model. So we use dots, points. So this is a particle model. We are ignoring the size of the ball. It's not important. Diagram showing the ball's position. Showing the ball's position. So let me show the position. Let me start coordinate system. Let me replace the origin of the coordinate system at the point when. Okay, let's say we can choose any point. Yes, if you remember. So let me choose this like this. This is origin 0, x, and y. So what is the position? This is the initial position. Let's call it R1. This will be second position. This will be R0. This will be R1 position. This will be second position. We call it R2. And this will be last position, R3. These are the positions. Now we answered for this part. Second question, average velocity vector. We need to show in terms of velocity vector. Let me choose different color. So this will be V1. Yes, V1, it's a vector. So that's why we need to use this kind of arrow above the symbol. This is a V2. And as you see, the size of the V2 is bigger than size of the V1 because it's accelerating downward. And this will be V3. V3. So it's we can see that V3, so just magnitude, the number of V3 is greater than V2. Yes, and V2 is greater than magnitude of the V1 because it's accelerating, velocity is increasing. So we just answered for the second part. Now it's your turn. Please draw the similar diagram for question number 6.